Hello students, so this is your plus 2 class chemistry lecture. In the last video we have covered that physical and chemical properties of group 15th elements. It's the P block elements 15 to 18. 15th group elements, their physical properties and chemical properties, in which we have covered key when they react with the oxygen, with the oxides are formed. When they react with the hydrogen, then hydrides are formed. Then reacts with the halogens, then halides are formed. They form halides, trihalides or pentahalides. Nitrogen not forms pentahalides because nitrogen is smaller in size, and second one is absence of d orbital in the nitrogen. That's why it not forms pentahalides, it forms only trihalides. After this there is a dinitrogen, that is N2. N2 means one property that we have done, that is catenation, that is self-linking between nitrogen and nitrogen. Triple bond is formed between nitrogen and nitrogen, it is N2, dinitrogen. How it is prepared? It is prepared when ammonium chloride, sodium nitrate reacts with each other and they form nitrogen, water and sodium chloride. So nitrogen is prepared with the reaction between ammonium chloride and sodium nitrate. Properties of nitrogen: it is colorless gas, odorless gas, tasteless gas, and it is non-toxic in nature. And next one is it is chemically unreactive, not so reactive in nature. After this dinitrogen, that next group elements are 16th group elements, in which the elements are oxygen, sulfur, selenium, and polonium. These elements are present in the 16th group elements down the group. First one is their oxidation state. Generally oxidation state is variable. It varies from -2 to +6. -2, +2, +4, +6 oxidation states are present in group 16th elements. It starts, first element is oxygen. Now in this case oxygen generally +6 oxidation state is not shown by oxygen, because in this case it is smaller in size, and next one is the first element, those again same points are there. It is smaller in size, it has a high electronegativity, high ionization energy, and next one is absence of d orbital. D orbital is absent in oxygen and it not shows +6 oxidation state. Polonium, that also again not shows +6 oxidation state. In this case there is a inert pair effect. It means when we move down the group, +2 oxidation state decreases, and another oxidation state +2 oxidation state decreases. Oxygenate generally shows -2 oxidation state, except in case of OF2 and O2F2. In this case their oxidation state is variable, but oxygen general oxidation state is -2. So +2 oxidation state, it decreases when we move down the group. +2 oxidation stability decreases, and another oxidation states +2, +4 oxidation state increases. But when we move after polonium, it not shows +6 oxidation state, because in this there is a inert pair effect. Next is atomic size. Atomic size generally increases when we move down the group, and electronegativity also, it depends upon the size. As the size increases, electronegativity also decreases with the increase in size. So it is related to the size. Size is inversely proportional to electronegativity. If size is more, electronegativity is less. If size is more, electronegativity less. If size is small, electronegativity more. Next one is next +4 and +6 oxidation state, that also decrease, means +6 is not shown by polonium. Stability of this +6 oxidation state decreases when we move down the group due to inert pair effect. Next is ionization energy, energy required to remove electron from the last shell. And in this 16th group element, ionization energy is less as compared to group 15. Reason is in case of group 15th elements, their electronic configuration is exactly half filled. Means in case of p orbital, exact 3 electrons are filled in the 15th group elements. So 16th group elements ionization energy is less as compared to group 15. Means group 15 have a higher ionization energy than the group 16. Reason is in case of group 15, exact half filled electronic configuration present. But in case of group 16 like oxygen, when we write the electronic configuration of oxygen, it is 1s2, 2s2, 2p. 2 to 4, remaining electrons are 4. So in case of P, 4 electrons are present, means 1 more than the exact half filled, 1 more than the 3, 4 are present. That's why their ionization energy is less as compared to group 15, and generally it decreases when we move down the group. Reason is same, with the increase in size as we move down the group from oxygen to sulfur, atomic number increases, size increases, and ionization energy decreases. Same way electron gain enthalpy. In case of oxygen, that is less negative in nature and enthalpy is less because it is smaller in size. Oxygen is smaller in size, and when we move down the group, size increases and electron gain enthalpy, that is become less negative. Next, there are melting and boiling points. Melting and boiling points generally increases when we move down the group because down the group size increases. With the increase in size, melting and boiling points also increases. Next, there are chemical properties. Reactivity with the hydrogen. When they react with the hydrogen, then hydrides are formed like H2O, H2S, H2SC, H2, selenium, hydrogen disulfide, water, H2O, when they react with the hydrogen, and their structure is bent-like structure. Like oxygen, it reacts with the water OH2. Same way sulfur hydrogen H2S is formed. In this case, their bond angle increases. Bond angle is highest in case of H2O, and it decreases when we move down the group. In this sequence, it decreases. Same way their acidic character is also related with this one, but acidic character nature is opposite to the bond angle because it is less in case of H2O and it is more in H2S than in selenium and selenium, because in this case when we move down the group, their bond length increases. With the increase in bond length, bond dissociation energy decreases. Bond length is more but bond dissociation energy less. That's why their acidic nature also increases when we move down the group. Reason is, when we are moving down the group, their bond dissociation energy is less and their bond length is more. Same with this one, with the acidic character, their next character is related, that is the reducing nature. In the same sequence, they are acting in the, reducing in nature. It means reducing in nature, highest is in the case of selenium, then selenium when they react with the hydrogen. It means with the increase in size, reason is same, when we are moving down the group, size increases, bond dissociation energy decreases and their bond length increases. Next one is reactivity towards oxygen. When they react with the oxygen, like sulfur dioxide is formed, selenium dioxide is formed when they react with the oxygen. Next is the halogens. When they react with the halogens, then halides are formed. And same way, the activity of halogens with the group 16th elements, that is increases in the same order: fluorine, chlorine, bromine and iodine. It is maximum in case of fluorine. It depends upon the size. In the case the size increases from fluorine to chlorine, bromine and iodine, their electronegativity decreases, and fluorine is more electronegative in nature, so that's why its reactivity towards with the 16th group element is high, and stability decreases when we are moving down the group because bond length increases. Next, in this case, like water is formed and H2S is formed. Water is liquid in nature and H2S is gaseous in nature. Reason is why it is in the gas form and why it is in the liquid form, because in the structure of water, band-like structure, and in this case the hydrogen bonding is present. This hydrogen bonding is strong in case of water because oxygen is smaller in size as compared to sulfur H2S, and it is more electronegative than sulfur. There are two reasons why H2O is liquid at room temperature and H2S is in the gaseous form. First one is oxygen is small size, and second one is it is high electronegative in nature. Electronegativity of oxygen is more than the sulfur and size is smaller as compared to sulfur. That's why it is in the liquid form, water is in the liquid form, and H2S is in the gaseous form. Rest properties we will discuss in the next session. Thank you.